Alright, good afternoon ladies and gentlemen. Welcome to my back deck for today's field trip video. We're out here for no other reason other than it's a lovely day and I really like the smell of my neighbor's Mayday tree and I'm really tired of being inside. So we're going to film the lesson on my back deck. So ladies and gentlemen, this is our lesson, or our field trip video for the lesson on gravitational fields. So, as always, we have our usual guest book, dynamicist, joining us because, hey, we're studying dynamics. We got to use dynamicist. And as well, also exciting, a new book guest is joining us today. We have Harold joining us. This is book 2, and it actually hasn't come out yet. It comes out tomorrow. As an advanced reader of the book, I have an early copy. So, awesome book. Comes out on May 26th. Have a look at it. So exciting. Great book. Okay, so these two books, book 1 and book 2, are going to be our masses that we're going to be using when talking about gravitational fields. Now remember that these books, because their mass is quite low in comparison to something like, the planet Earth, we are going to have a significantly lower value for our gravitational fields. Like we're talking like times 10 to the power of negative 11 newtons per kilogram here. So once again, why? Remember, the value of big G is like 6.67 times 10 to the power of negative 11. So one tiny piece of gravity, as I like to think of big G, is diminutive. So you have to have a huge mass and actually to have it the gravitational field an object can emit actually have a significant value. However, because remember how I mentioned in the lesson video that you're going to be needing to look at the interaction of two fields for next year in Physics 30 and how it shows up, I'm pretty sure twice on your assignment. We're going to do another video here on this topic. So I'm going to adjust the camera so you guys can see the books. And I've got on a towel here so they don't get dirty on the deck. So my dog gets muddy in the backyard and runs all over the deck. All right, can you guys see the books okay? Yeah, I hope so. I'm going to count that you can here. All right, so here we have two books. We've got Dynamicist and we have Harold. Now, these two books, because they have mass, these two books, have a gravitational field interacting. Okay, this guy's exerting a gravitational field. This guy's exerting a gravitational field. Now, ladies and gentlemen, remember from our video that each of these books, every object, every mass, has a gravitational field that's attractive. Gravity is always an attractive field. So that means that Dynamicist is going to be pulling this way. It's going to be having its gravitational field coming out this way. Harold is going to be having the gravitational field going towards it at all times. Okay, so ladies and gentlemen, what that tells us is these two fields are interacting. Dynamicist's gravitational field is going this way. Harold's gravitational field is going this way. So if I use this fancy ceramic button here, and put that in the middle, that, ladies and gentlemen, can be our point P. So at point P, we have a gravitational field going this way and a gravitational field going this way. Okay? Sounds good? All right. Well, let's rearrange the books a little bit. Let's put Harold there, and let's put Dynamicist here, and let's make point P here. Now, what I have, ladies and gentlemen, is I have created a right triangle. Now, remember with our right triangles, this is where we're going to be needing Pythagoras. So Harold is going to be, once again, having a gravitational field going always this way, but at point P, which is represented by this button. So it's essentially what the gravitational field would be at the button. So at that point, it's going this way. Okay? And point P, Dynamicist, is going to be pulling at point P this way. Even though its gravitational field is going in all directions, pulling towards it, point P is where we're concerned about here. So if we're being pulled this way and being pulled this way, it means the net at point P is going to be this way. Now remember, how we get that value is we add our vectors tip to tail. Okay? So, ladies and gentlemen, that's just more of a nice visual about how we would set up a question like that. So, I hope you guys enjoyed coming out to my back deck to enjoy the lovely Mayday tree, beautiful Mayday. Make sure you guys get some time outside and enjoy. It's beautiful. Get some sun, wear sunscreen. Okay? And if you guys are looking for an awesome fantasy novels to read, they're awesome. Give them a read. And a lot of physics in these two guys. So much physics. One of the reasons they keep showing up is these are like all physics books. Okay. All right. Ladies and gentlemen, hope you guys enjoyed. Have a good rest of your day. And stay out of trouble. No fires, injuries, or explosions. No, I can't stop the video. Where's the stop button? There we go.